The most common thing people said about, what 2 or 3 specific aspects could have been improved, overwhelmingly the most common thing that people said was more time. Which, is fair enough. I think that's problematic, but it's better than having them say less time. Right? So it's not the worst thing that people could say. Now, I decided to make a judgment call and let you have more time to talk to each other at lunch and to start a little bit later so that you'd have time to work together. In about 10 minutes, I could probably finish what I might have done if we had started a bit earlier. And we can talk about the other pages in that handout. Would that make you feel more at ease if we touched on what the rest of the handout was? All right. Do you ever find yourself in this position that you don't get as far in a class meeting as you hope? Does that ever happen to you? I've taught for 35 years. It still happens to me. Sometimes I just don't gauge it quite right? Or something happens, we get off track a bit. So I have to deal with this, and I'm sure you have to deal with this a bit. So sometimes I have to sort of circle back and say, okay, let's pick it up. So let me ask you to reflect on this for a minute. Take a look back at the pages that we did get through. And I'd like you at your table to decide if there's anything in the parts that we talked about that you'd like me to comment on. Do you have any questions over the part that we did do that are shared at your table? And I'll be happy to answer any questions that several of you have. Not that one of you has, but that several of you have. And if not, we'll just move on. We'll pick up at page 6 and we'll take a quick tour through the rest of this. Okay? Yes, ma'am. I don't want to hear a question from you.
We're curious about the bus test, parent test, the parking lot.
So you've already talked about that. Yeah, right. So they're going back to page 1 and saying they still want to know what the bus test, the parent test, and that is. Okay? Any other tables where you've discussed what you wondered about and you have something you want to raise? If not, take a minute and see if there is. So just in the first pages that we actually talked about, is there anything that you want to talk about? In the part that we talked about. Are you ready? So, we could spend more time on this, but just from the balcony, one of the things that I often do with my classes is I ask the students to think back at the last exercise, the last homework they had, the last assignment they had, the last class meeting, and to discuss whether there's anything that we need to go over. I don't take questions from individuals. I typically teach between 120 and 150 students. So what I do is I take questions from groups and I say to them, the groups, you can decide, and in your group, if you come up with 1 or 2 questions that all of you really want to answer, send that to me, through the LMS, and those are the questions that I'll privilege in class. Because I'm a utilitarian. I'm trying to do the greatest good for the greatest number. And what I know from research on my own practice is that what people sometimes say about questions is not true. Have any of you ever heard somebody say, don't worry, if you have a question, please raise that question because probably a lot of other people in the class have that question too. Have you ever heard anybody say that? Have you ever said that? I've said that too. So in the 1980s I'd been teaching about 10 years. I began assessing students' learning in different ways. And what I soon found out, like within a month, was that's not true, in my classes at least. That students have a wide variety of questions, and most of them are not common. So if I let one person ask a question in class, it turned out that most of the rest of the class wasn't interested in that question at all. Now think back to your school days. Do you remember that in class? Somebody would ask a question, the professor would answer it at some length, and you would have time to daydream or, Now students have time to buy shoes online, But the issue here is that What I want to do is find out what the common questions are. And the LMS, in your case Blackboard, gives me an easy way to do that. So I can go back, in class and say to you, I now know what three questions most of you care about. Those are the ones I'm going to spend some time on. Others have individual questions. In some cases, I might respond individually. And because I've been teaching the course for a long time, I can put up answers I've already developed for other students. And I can say, a number of you had questions about these things. Here are my responses to those. Or you could read about that in these pages. But in class, I'm going to take on the highest order questions that I think you will not understand even if you read it again, that I think I can help you with. So let's hear a couple of those. So we've got them asking, what's the bus test? What's the, I'll make that clear. Anything else over those pages we looked at? Yes, sir.
I have a question about...
Did they share your question? Did the rest of them share that question? Did they care about it?
Yes.
Okay. I'm dubious about that, but all right.
Explain that to students. I could see some students feeling disenfranchised potentially.
Sure.
So I'm curious. I'd like to hear more about the process piece because we start school next week, and I want to try to integrate some of this. So how do you go about if you've had students?
I understand your question.
I'm a counseling professor. In a lot of our
I understand
classes,
your question.
Okay.
I'm not going to answer every individual's question. Who gets angry? The A- students and the B+ students, because they're used to getting all the attention from the professors. They're the ones who always raise their hands. They're the ones who always answer in class. And they're used to getting all the professor's attention. The problem is other people need attention too, right? And you may have small enough classes, it's not an issue, but if you have big classes, you can't, everybody couldn't answer a question. You couldn't answer everybody's question in 60 minutes if you let them all ask one. So what I want to try to do is to do some triage where I get them to raise questions, answer the ones they can answer themselves, then see if they can help each other, as we did in here, answer questions, and then bring to me only the ones that they can't do, right? And so to do that, I basically say to them, look, class time is precious. To be fair and to get the most value for most of you, I'm going to allot class time, the face-to-face or online time, to questions that are shared by a number of you. If you have an individual question, I'll try to answer that via email, if you email me. And I'll answer it in this many days. In my syllabus it says, I will respond to emails within 2 working days. I often respond faster than that. But, I say, Monday to Friday, I'll respond within 2 working days. You might want to say 3 working days. But what I say to them in class is, I am not going to stop what we're doing to answer a question unless it's a clarification question. So I say, if you don't know what I'm asking you to do, or if you're unsure what we're talking about, stop me and say what. But if you just have an individual question, I'm not going to stop class for that with 150 people. Because it's not the best use of our time together. Write the question down and send it to me. And they do. They have that access now. The only people who get bent out of shape are the ones who all their lives have gotten all the attention. And I just have to live with that. Sometimes I've had to say to students sometimes, I know you're used to dominating the discussion. I don't say it in that way. But here, that's not going to happen. You're important. I'm in charge. This is the way I run this. And the reason I run it this way is I want to make sure that I give the most attention to the things that most of you need. So you have other outlets. You can email me. You can come and see me during office hours. Nobody goes to office hours anymore. That just doesn't happen in my university. I don't know if it does here, but we rarely see students in office hours physically, unless they're coming to complain about their grades.
Yes.
Right? Once in a while, they'll actually show up physically to complain about grades. So that's why I do. But I want to be really clear. The things that I'm talking about today, I'm not suggesting they're things you should do. They're just possibilities. It might work really badly in some disciplines to do that with students, And you might want to say to them, ask any question you want. No matter what our agenda is today, I'd be happy to just give that up and stand here and answer your questions. Maybe that's the right thing to do in some cases. It doesn't work for me. In stats, I've got stuff that we've got to get through. So Were there any pages that came up and you said, you know, we ran through this, I had no idea what that meant, what that page was about? Mm-hmm. Right? And some of these things maybe I'll be able to make clear. On page 6 of your handout, there are these things called concept tests. You guys, how many of you are familiar with concept tests, that word? Not so familiar. It's not rocket science, so it's a name for something that I'm sure you've seen before. But it turns out that in the last 10 years, maybe more than 10 years, people have, in the STEM field, science, technology, engineering, and mathematics. Are any of you from a STEM discipline? Few, okay? Welcome. In the STEM fields, they've done a lot of work with money from NSF on these things called concept tests. So I want to show you a couple of examples and then talk about why they're important. And it turns out they're a very efficient and powerful way to use technology and social technology to help students learn deeply. And I'll try to show you what people do when they do that. So on page 6, there's a concept test at the top from one of my classes, and it's about variance and standard deviation. So in each row, what I'd like you to do is circle the item in each row that you think has the largest variance and therefore the largest standard deviation. So the first row is human heights or human weights, right? Am I right? Mm-hmm. Adult human heights and human weights. Circle the one that you think is more variable, heights or weights. Not a trick question. And then dogs or cats, which one is more variable? And then so on, till you've done all 4, okay? Everybody know what I'm asking you to do? So let's do number 1.1 together, okay? And see if we're all on the same page with this. What's more variable? In other words, you know, what would have the largest standard deviation if you know what that means? What's more variable, humans' heights or weights? Anybody think it's heights? Well, have you ever been to a mall? Like Dallas has a big mall, right? With a skating rink in it and everything, right? Ever been to a county fair? Huh? So if you look around at large groups of people, one of the things you'll notice is that there are people who are, let's say, my height, but weigh 2 or 3 times more than I do, right? And less than I do. But there's nobody 3 times taller than I am, right? It just doesn't happen. So we know from experience of everyday life that weight is more variable than height in human beings, I think. And students would know that. What about dogs and cats? Which is more variable? Their weights. Domestic dogs and cats. Dogs, right? So there are little rat dogs and there are huge horse dogs, and there's everything in between. But cats, even though there are bigger cats and smaller cats, they're all within a factor of about 3 or 4. Dogs are a factor of about 200, you know? And so dogs of all species, they're the most variable in size, and that's because we made them that way, right? So that we could carry them in purses, you know? Or little children could ride them. I don't know. You know, it's all kind of weird. But if you let dogs breed back, they all turn back into something like dingoes after a few, you know, dozens of generations. That's what they were, you know, all sort of one smallish size. Let's jump to 4. What about hours in the classroom versus hours studying? Which is more variable? Studying, yeah, because the hours in the classroom is finite, and we know what that is. But studying, some students don't study ever, and others study an awful lot, so it's a big range. Before I try to teach them anything formally about what standard deviation and variance mean, before I teach students how to calculate that, which, you know, for some of them seems hard, but it's sort of a trivial thing, really. A machine does it most of the time for us. I want to know, do they understand the idea of variance, and can they connect it to their everyday life? You know, do they know what it means in daily life for things to be variable? And the answer is they do. They just don't have a word for it or a concept for it. So one of the things we know is for people to learn, they have to connect new knowledge to prior knowledge. If they can't make a connection between new and prior knowledge, they won't be able to remember it long enough to process it. So it won't get into deep memory. So a big challenge for every teacher is helping students find that prior knowledge to connect to and making sure they make the right kind of connections. a famous English novelist. He was famous at the time, not so famous now. G.K. Chesterton wrote, "Learning means connecting things and stops when they cannot be connected." He wasn't a neuroscientist, but I mean, that's pretty much sums it up. Learning means connecting things and stops when they cannot be connected. Now look at 1.3. And let's just do a poll here. How many of you said language? And how many of you said math? Now we've got variation. And the other ones you pretty much agreed, that's this answer that. 1.3 is a bad question. Because to answer 1.3, you have to know things that every 18-year-old doesn't know. And that you might not know if you weren't a person who knew a lot about child development. So as I'm writing questions for concept tests, I have to go through them and take out ones that aren't things that people know from their everyday knowledge or from their prior knowledge of the discipline. And that would be a bad question. I'd strike that one. The answer is actually mathematics. Because all 12-year-olds, no matter whether they live in the Brazilian rainforest and are illiterate, or if they live in Shanghai and are hyper-illiterate, they all have about the same oral language development by the age of 12. But mathematics is variable. In the city, I'm sure we could go from school to school, right? And 12-year-olds would have very variable math. It's a cultural artifact. So my question for you thinking about this is, are there any simple questions that you could ask like this that would get at your students' conceptual understanding? That's what a concept test is. It's a question about the concepts that you're trying to get them to learn that can't be memorized and it can't be looked up. It's got to be a question that students have to think about. And by the way they answer it, you can tell whether they understand the concept or not. Let's try the next one below it. See the little graphic that's green and black or green and gray? This is important. You must answer the question within the limits of that graphic. You can't think outside of that little picture, okay? So read the question and answer it by circling A, B, or C. Just A, B, or C. If you're not sure, just go with the one that you think it is, what your gut feeling is. Everybody got an answer? Right, let's poll you. Again, I'd be doing this with the LMS. I wouldn't do it in person. It's a little bit threatening sometimes for students to do it in person, but it's also better for me to know ahead of time where they are. How many of you said C? Did we get any C's? 3 or 4? B. A lot of B's. A. So B's and A's are almost equal. Now, at your table, quickly convince the other people why you're right and they're wrong in the nicest possible way. You got a minute. Have you changed your mind? Have they convinced you? How many of you would change your answer now based on what you've heard? Okay. Now see, that's what I mean by students teaching each other. Now we don't know if they're right. So we don't want to leave them in pooled ignorance, right? That wouldn't be good. We need to check on this. But does anybody, can I get somebody who thinks it's B to explain to us why it's B? Why that's a good answer? Yeah, would you tell them?
I think the hazardous waste should go in an impermeable rock so that it doesn't spread all around. It has to be stopped somewhere. That's what I thought.
I've got a reason for answering that. Is there anybody who thinks it's A who would like to explain to us why it's not B? Why it's A? Would you?
Then you've got impermeable right above it, then it can't go up.
How about below?
Yeah, but that's away from the water tables, and that wasn't on the chart.
It's not on the chart. Looks like there's impermeable rock below it.
Well, yeah, I would just say right in that.
The B is impermeable, and trying to inject something into it is not going to, is basically going to back up and come out.
Concept is this testing students' understanding of permeability, right? And if students have done the reading and they've answered this question and they've given any answer other than A, and many students will, this is one that one of my geology colleagues uses, then that means they still don't understand impermeability. Because by definition, the impermeable layer, you can't get anything into it. If you try to pump anything down, it'll come right back up the well. But people have logical reasons why often they give the wrong answer. And the key to it is, here's from the balcony. The key to it is not them memorizing the right answer, but them getting the right way of thinking about it, right? And so what I want to do, and what he wants to do, is find out why did they answer that way, and can we get them to, bring that up to an explicit level so that we can work on that. And sometimes the other students can explain it in a way that's better than the way that I can explain it. But in the end, I want to get back to them and say, okay, well, let's see what's really the best answer, geologically speaking, we would say, in this, and check that, and then get somebody to explain it. So you might ask yourself, are there concepts in your teaching next week or the week after that you could assess in this kind of way? Now, if you're in a STEM field, there are banks of these questions online that you can look at. And if you're in other fields, some other field, parts of psychology, parts of history, there are also banks. And in some textbooks, increasingly, you can find these. You could make your own, but it's kind of hard. It takes some time. So if you can find them, you might want to find them. Are you going to teach any concepts in the first week? I hope so. I hope so. Or they're going to learn some. So this is something that people use to check on that. And when folks are doing this, on using digital technologies, students are often using clickers. Do you have clickers here? Yep. Their personal response systems, or they're voting online through the Survey Monkey kinds of things. And then the prof comes to class and says, here's what you did. Here's the distribution. Let's see which of these answers is the best answer and why. So they're actually checking on students' understanding and then tearing it apart, putting it out on the table and saying, what does this mean? And that's really, for many students, how they get to understand the fundamental concepts. Otherwise, what they're going to try to do is memorize the right answer. And the problem is, if you change the question, leave the concept the same, but change the question, they won't be able to answer it. Because they've solved a problem, but they haven't engaged in problem solving. You know what I mean? So students in stats, I can write a problem about Cleveland, wildebeests, and buses. And if I change that problem and change only the nouns and make it about Akron, gazelles, and semi-trailer trucks, students will say, you haven't taught us how to do that problem, right? We've never seen that before. That's unfair. You can't ask us that. And when I say to them, in the world, you're going to get problems you don't see in class or in the book, The key is to prepare for those, not for the ones that, I'm going to give you. So that's one of the ways that we do that. Now, let me just take another minute on concept tests, because they're a really powerfully research-validated way to help students learn. Why do they work when they work? They work because they draw on these things. This is not in your handout. This is just an FYI. They're focused on the key concepts in a discipline, the most important things. They require students to predict and have some skin in the game. And I'm going to illustrate this in a minute in another way. They get students to discuss the problem or the concept in a useful way. They require them to make a commitment to an answer, like me asking you, circle the one you want to do. And if you can, again, you can change that maybe later, make another decision. And students then get feedback from each other and from the instructor in that case. So those are the things that make them work when they work. Now I think I have, if I can find it, I think I have something that I might be able to show you in this regard. So what I'd like to do here, this is a dean talking, so we'll ignore her, not because she's female, but because she's a dean. But seriously, as soon as this lady stops talking, there's going to be an example that comes on that I'd like you to watch. Right? This is just before the example comes on. And what I'm going to ask you to watch is a kind of concept test, but done as a demonstration. In other words, it's very live, active sort of thing. With me?
Do by way of leadership has to take account of the fact that the sort of primary energy for change has to come from people on the ground that are doing the work.
What helped me move along is I belong to a group of 4 folks here who do research on learning physics. So we all interact, we all talk about how do we do these things better, how do we design questions to get at the right kinds of conceptual knowledge that we're after. So it's a strong support group.
Jose Mestre teaches a large introductory physics course. He and his colleagues have been experimenting with several new technologies to help make their courses more interactive. Class Talk uses graphing calculators to record and tabulate student responses during a lecture, enabling even a large class to work together. The students discuss the question and then register their hypotheses on their calculators.
Some people have set 1, moved over to 2 now.
Their answers are instantly projected on the screen in the form of a histogram.
I used to lecture, and then I found that students learned some things, but they didn't learn some other things that I wanted them to learn, such as conceptual information.
Then what did you do?
I put in 50 for VB.
And then along came this technology that allows me to pull students and to run the class very interactively.
I have here 2 steel balls. They're identical balls, and I'm going to release them from up here. One that's closest to me is going to go down this ramp here, then go straight all the way up to here and fall to the bottom. The other one is going to go down an identical piece of ramp, go straight for a little while, and then it dips down lower, and then it goes straight till about here, and goes up to the same level as the original track and falls in the bottom. Okay? The question I'm going to ask you is what would...
Is the same question I'm going to ask you. All right, so we've got this demonstration that's going to happen, and he's going to ask them to predict what's going to happen. Which ball is going to get there first? I'm going to ask you to predict the same thing. So there are 3 possibilities, and I want you to write down, in other words, I want you to commit yourself to your prediction, one of those. The first possibility is that both could arrive at the same time. So if you think that, you write same. The second possibility is the one on the flat track, it's a little bit inclined, could arrive first. If you think that that ball will arrive first, you write flat. And the last possibility is the one on the dip track that goes down and comes back up, could arrive first. If you think that, write dipped. So I want you right now, just anywhere on that page, to write down same or flat or dipped, depending on which you think will arrive first, or whether you think they'll arrive at the same time. Don't talk about it, just write. Did you write?
They both begin at the same height?
They begin at the same height, yeah. There's nothing tricky about this. So, we're doing this. They've got personal response systems, in this case they're calculators, and he's seeing them vote, but we have to do this the old school way. So, how many of you said same? Look around, see how many hands up. Wow, lots. Flat. Just a few. Gosh, you people are so tired you can barely raise your arms. It's good for your heart, actually, to raise your arm. It's good for your circulation. Dipped. Got a few. So most people think same. Quite a few people think dipped, and only a few think flat. Do you want to see what happened? Even the people who are facing the wrong way. Do you really want to see? Do you see that you've been manipulated into caring about this? Yeah, well, so. Teaching is manipulation. The question is, are we manipulating people for the right reasons? So I'm going to show you. He's going to talk for a minute about what he's doing, and then you'll see it. But it goes by really fast, so you got to watch quickly. You'll find out if you made the right prediction.
First.
So it's a much more interactive way of teaching. And the students don't fall asleep the way they used to in lecture. Everybody's nodding off. Now it's a very noisy, loud environment. So you never know quite what's going to happen.
Ryan, what's that?
I think it's 2.
I find it exhilarating. because part of the fun of it is figuring out what the students don't know and how you can get them to come around to learning the things you'd like them to learn.
Okay, the count of 3, 1, 2.
This program showed that many of the students had predicted the wrong outcome, leading the class into a lively discussion of the physics that underlies the demonstration.
And I hear a reason you always want.
At the bottom where there was greater kinetic energy, actual energy that was being used, that was where there was more speed. You see what I'm saying? When there was more potential energy, less of the energy was being used in the motion.
As potential energy gets converted more into kinetic, this one is going faster and beating the one on the top. Is that your reason? Did I paraphrase it okay? What do you think of that reason? They both arrive here at the same speed, but by now...
Student-active teaching doesn't require a well-endowed college or expensive technology.
Sure does.
Got to have lots of money. Money, money, money. It's all about the money. No. So he's using, somewhat sophisticated stuff, but you don't have to have that. You can do it old school. But here's the point, and what I want to draw your attention to. What he's doing is he's doing a demonstration that people have done in physics ever since Archimedes, probably. And if you took physics, you probably saw somebody do this, basically the same. Every physics class now still has it, and there are a million of these online, this same demonstration. The only thing he's done is he's tweaked it by stopping and saying to students, now what's going to happen, right? So that they actually have to think about it rather than just watching it happen. Now what's going to happen? Why is it going to happen? Then they get to talk to each other about it and find out that other people even in their study group don't agree with them, and see if they can sort that out. And then and only then do they see it. So there's a staging here. Question is posed, students have to make a prediction, they get to discuss their predictions, then they get to test their prediction against the reality, what happens. And you saw that some of you amazingly got it wrong. How this could happen in a room full of people who have PhDs, I don't know, right? Great failure of American scientific education, apparently. Why would you know? You wouldn't know, right? You wouldn't know any more than the students would know. And when they're talking, when they discuss it, one of the things that he pulls out of them is, why do some students think it's going to be the one on the flat track that will get there first? And why do some of them think it'll arrive at the same time? They have theories, but they haven't articulated those yet. And he wants to get those on the table so he can work with them and help them understand how that's a reasonable thing to think. It just doesn't work in physics. And the reason why it doesn't is the explanation that Brian gave, right? That's what they have to learn, and they have to learn it in such a way that they understand it when he changes gazelles to wildebeest to mules and back, so that no matter how he cloaks the problem, that they can still see that it's the same problem, right? And that's what he's trying to do. But by good concept tests, by the wrong answer that they give you, tell you something about their thinking. Because there are common misconceptions in some fields, and in physics they know a lot about the common misconceptions that students have, right? So while I'm going back to my PowerPoint, any question about what he was doing that you wondered about that wasn't sort of obvious? What was going on with that?
What challenges you had to do that in a traditional?
Online teaching of physics, you'd see that they do this stuff all the time in online courses. And the challenge is building or setting it up in such a way that students can't see the rest of the demonstration until they can't progress until they've actually made a commitment or answered the discussion question. So that's really, it's a technical problem, but that's kind of all. But you'd see this very example, you could look, you could see online, you could see a number of different examples of exactly this thing, some better than others. So you did that, you predicted, and in the end, which one was it? Dipped. And I'm sure you're now ready to explain why, right? That would be the hard part, explaining why, and why not the others. Now, this is not in your handout, because I don't believe in putting everything in the handout. Do you have students who say that who basically think everything that about the course should be in your PowerPoint? I don't think that's a healthy way to teach, basically, in the end. So I say to them, look, there are going to be things that happen in class, and then I give people in class that you will not get if you don't come to class, in face-to-face classes. And they say, that's not fair. And I say, probably not. But remember, you're important, I'm in charge. So here are the steps behind the most powerfully supported approach to teaching that we have. So a lot of different approaches to teaching have been researched, and in general, this approach, the 5E model, seems to be, not for everything, but for teaching content, the most powerfully supported way to do it. In other words, there's more evidence that doing it this way works than any other thing we can do. You could look this up. So I'm just going to go through it and say what it is, and it's what he did. It's exactly what he did, but I'll show you why. First, you got to engage students. Duh, right? You got to get them interested, and in this case, is by asking a question, posing a question that has more than one possible answer. In this case, then eliciting their answer. That's when he makes them, bet. They got to put their money down. They got to say, I think it's this or this, right? It's A, B, or C. It's 1 or 2. Which one is it? That's the elicit part. The third part is where they discuss their answers when they have different answers and talk about, why did you write that? I don't think that's it. What is it? They try to convince each other, and that's where they're actually making what they think explicit, right, and beginning to think about it. And in one of the cases that we did, some of you said, I've changed my mind after I talked to other people about it. And this happens to students too, and that can be a good thing, if they're right. We have to check that. Next, getting them to explain, right, the right answer, once they know what the right answer is. Because it doesn't help them to know it if they can't explain why that's the best answer, right? They're just memorizing. So do you remember some of you asked me, what was the parrot test? What was the bus test? Okay. Well, the parrot test is this. If students can answer the questions that you're asking simply through rote memorization or cheating, then a parrot could pass your test and your class. So your course fails the parrot test. The parrot test is that. If students can pass your course simply by rote memorization and or plagiarizing or cheating, then you fail the parrot test. That can't be higher education. That's something else. I don't know what it is. So the explain is that's the parrot test. That's where we find out if they get it, they really know it. And the last part is elaborate. Taking it and doing a different question, answering a different question about the same material that looks different to see if they really get it. So in physics, these concept tests about each concept, there are several different ones that test the same concept so that you can retest them and see. Here's the problem. They're online and students can find them. And they will. So teachers now have to keep changing them a little bit so that the ones that are online aren't the ones that students see in class. Right? Otherwise, the students memorize the ones online, being good parrots, right? And they still don't understand what they're doing, but they have the right answer. That's not what we want. So this model, the 5E model, is really powerfully backed by research as a way to help students learn deeply. It's not the only way, but it is a way. Does that make some sense? And like a lot of these things, they've turned it into words that are sort of alliterative, begin with the same letter, but you could use different terms for these and that make more sense to you, and it might be more helpful. There's also a 7E model and there's a 6E model, and people need to publish, so they do that, but they're not so different than this. They all contain these 5 as well. So I've just revealed to you one of the things that has been researched for many, many years, especially in STEM, but not only, and that is sort of a secret behind good class and course and activity design. Many of you are doing this already, but you probably don't think about it in sort of a stepwise fashion, right? And this is just a way of making that more explicit. Enough on that? Yep. If you want to write down anything about that on page 12 to remind yourself, this might be a good time to say, here's a note. I might want to think about X or Y or Z next. So here's a question for you. If I ask you to write something and I start talking, does that help you?
Oh, no.
No, it doesn't, does it? Right? So one of the key things I have to do, and one of the hardest things for me as a teacher, is to actually shut up when I'm asking students to do something. Because people can't multitask. No matter what people think, there is no such thing as multitasking. You can't do two things that require conscious effort at the same time. You can do one thing that requires no thinking, that you've made automatic, like ride a bike, or drive when nothing's happening, and think, but you can't think about two different things. All you can do is switch. So if I want students to think about what I've just said, I have to stop talking. And if I want them to pay attention to what I'm saying, I have to turn off the screen. And if I want them to read the screen, I have to shut up, because they can only do one of those things at once. Otherwise, I'm dividing their attention and making it less efficient. And that's a hard thing for me to remember, but it makes it easier for students to follow if I remember that. So when I ask them to write about what they're learning, I have to be quiet for a couple of minutes and let them write. Do all of them write about that? No. Some of them immediately pull up their phones and start looking, right? Now, that irritates me, but it doesn't do any good if I show my irritation. So I just try to let it go by and I concentrate on the students who are doing what I've asked them to do and just ignore the ones who aren't. How many of you think it's important, or very important, that your students use what they learn in your course outside of your course somewhere? How many of you think that's important? Now, if you're not raising your hand, you're supposed to raise your hand. Right? Because otherwise, what are they doing? If the only place they use it is in that class, that's a really expensive, experience going nowhere. Right? So all of us care about application. And in fact, if you study what faculty value, as I've done and other people have done, and you do surveys about that and interviews, it's always either the top thing faculty say is important or the number two thing. And it's usually number one. So if you say, what are you trying to do? Faculty in one way or another will say, I'm trying to teach students things they can use in the workplace, in their lives, in their home. And almost everybody says that in one way or another, understandably, right? The question is, how do we help students do that? Because the research on application or transfer of training, some people call that, is quite clear that most students struggle with that. They find it hard to take what they learn in the classroom and use it outside. And mostly they don't. Mostly they don't. Not your students, but students in other universities, not the ones you went to, not the ones your kids go to, other universities and colleges. Application's hard. So one of the things we know is that if we want students to do it, we can train them to apply what they're learning, but we probably will have to, in many cases, train them. So one thing I do is I make my students in all my courses keep an applications log or an applications blog. It used to be just a written thing on paper. And I ask them all the time, every class, to write down what they're going to use from that class, from that activity, from that assignment. How are you going to use this at work? How are you going to use this at home? How are you going to use this, depending on who I'm teaching, how are you going to use this in your major? How are you going to use this to help you write, your papers? And I prompt them to write about that. And every once in a while I collect examples of those and share them with class and talk about them. What people in the best research on this has been done in engineering education. What people have learned is that application, that skill is like a muscle. You can train it and get better at it. And one of the ways to do that is to actually focus students' attention explicitly on that and get them to do it repeatedly. And ideally, to give some feedback once in a while on that. So if you care about applications, you may have to devote some time and attention in your course to that with students, because they won't normally do it on their own. A few will, but the majority of them will not think about how am I going to use this at work or in my life. They'll just learn the stuff like parrots, and move on. And I know that's not what you want. So let me give you 30 seconds to think about how you could make it more likely that they would apply what you work so hard to teach them. And I'll be quiet for 30 seconds. If you can think of an idea, jot it down. Now, here's one of the great advantages of online learning. In online learning, students can decide how much time they need to write or to read something. And not everybody, in a classroom when you do these kind of things, I always give too much time for some students and not enough for others. And it's very frustrating. And it's distracting. But when you're online, you can decide how much time you need in many cases for that. And if you're really quick, you can zoom through it. And if you need a lot of time, you can take the time you need. If English isn't your first language, you will always operate slower in your second or third language than in your first. No matter how smart you are, right? That's just the way it is. So online learning has lots of potential, or blended learning, lots of potential to make what we do more equitable, fairer for more students, and also less frustrating for the students who are better prepared or maybe more quick. And so it's not all bad. Some of my colleagues think it's all bad. There are a lot of advantages to it. So on page 7 is just another one of these group work sort of things, very simple group work things. And this is sort of not there, but this is why I'm sharing those and not others. Because they're easy to use, they're simple, not much bad can go wrong. You could read about that if you want to. I'll be happy to answer that. Page 8. Take a quick look at page 8. How many of you use any kind of group work? Anybody? A few, right? So would you look at this page and circle the one of these 5 that you find the most difficult or the most problematic? So out of these 5 things, which part of it is most problematic for you? Which one of these? See if the other people at your table agree, and we can take a minute on 1 or 2 of these that are widely shared. So see what your colleagues circled. What's most difficult to deal with in group work?
It gets back to what's the pre-write to close it. Because usually that's the problem, right? That there's some smart person doing all the work. There are 2 grades.
Well, there's individual if you ever decide to. Still, they might.
Yeah, it gets back to what's the pre-write to close it. Because usually that's the problem, right? That there's some smart person doing all the work. There are 2 grades.
Well, there's individual if you ever decide to. Still, they might.
How's this going to
They give everybody.
They have to report how they did it and who did what.
Well,
I mean, it's all.
yeah, I've had a reassessment over the years because I discouraged
I mean, my partner Dominic, who's in the program, you can see that, that collaborative work.
Step up to the balcony. Imagine, your students, and I basically say to you, look, there are 5 big things that we've been discussing or we're going to discuss, or 5 pieces of literature that we're reading, or 5 big, theories that we're dealing with. And I'd like you to talk about, and work with your study group to decide which one of these is really the most difficult. So even in talking about that, that's going to help some of you clarify some of the issues. And then I can get a sense of where I should put my effort. I may still have to deal with all 5 things, but I can decide, where I'm going to differentially put my time in the instructional part. Or if I have tutors or if I have people who can help with this, I might say to them, the students are really struggling with 3. Let me give you some help with that so that you can work with them individually. Because if I don't give them a heads up, it's going to be really difficult often for the tutors in the learning center to be very helpful to the students. So this is a way for me to get students thinking, for me to assess really quickly where they're struggling again, where they think it's really difficult, and then make some decisions about how to allot the scarce resource that is teaching to that. How many of you circled 3? How many of you circled 4? Were there any others that people circled? What'd you circle? 1. Number 1, okay. How many circled 1? Just a few. 2? Just a few. 5. All right, quite a few. So if it were me, I'd come in and be ready to deal with sort of allotting time in this order to 3, 4, and 5. And I'd say to the folks who are struggling with 1 and 2, talk to the people in your group first. And then if you need help with 1 and 2, email me, if I need to set up a time, or, I'll get time with the tutors so that I can now focus my time on the things that they care most about. A number of you indicated you were interested in ways to help improve student motivation. Yeah? Okay. So the research on this is quite clear that in countries like the United States, cultures like the United States, choice enhances motivation. Too much choice confuses people, but a small amount of choice enhances motivation. So one of the things I try to do is put choice points throughout my course where students can tell me, I'd rather do this than that, I need more help with this, this question's more interesting to me than that, so that I can give them choices that are, within the realm of what we're going to do anyway, and I can respond to those, because I know that will enhance their motivation. That'll make them feel like, this is more about me, this is responding to things I really care about, in ways that do no damage to what I'm trying to do, and that in fact often help me figure out better how to do it. So if you can think of ways to put choice points in, even really small choices can make a difference in students' motivation. Do I need to say more about that, or is it sort of obvious what kind of choices you could allow them to make? I'm not saying allow them to learn something or not learn something that is key to the syllabus. That's not going to happen. But I might change the order of those things based on their feedback in that regard if I can. Or I might give more time or less time based on their choices. I always try to have at least one assignment in which students can choose a topic to pursue, to do research on. I have veto power over those topics, but, and they have to run them by me, but that's one of the ways that students, and that people have done for years, that students exercise choice and gets them to involve themselves in the course. And that works. People have done it for hundreds of years probably, and it's one of the ways that's always worked for a lot of students. So if we were doing a workshop on these things, then I would say, okay, we're going to build the workshop. Suppose I lived here with you. Wouldn't that be scary? And worked here. Then I'd say, okay, well, most people seem to really be hung up on these last 3. Let's do a workshop online or face-to-face on those things and focus on those. We don't have time for that today, but there's a lot you could read about that. And if any of you are really interested in that, let me know. You can email me, and I'd be happy to suggest some short things you could read that would be helpful. The main thing I would say is, unless you're really good at group work, don't give group grades, because you'll be in a world of pain unless you've really thought that through carefully. Give individual grades, right? And use the groups to help students study more effectively. I'll say more about that later if you want. Page 9. My question for you on page 9, what does this guy care about and how do you know? So you're a student in his class, first day of class, he shows you this rubric. What does he care about? How do you know? What's most important to him? Not a trick question. Argumentation. How can you tell? It's worth more points, right? So it's worth 40% of the class points. What's next most important? That's worth 30 points, right, out of 100. What's third most important? So the striving for excellence and creativity. So that's his fudge factor. So this is a third-year economics course my good colleague was teaching. Students are going to do 2 things. They're going to take a couple of big exams over the content, and they're going to write a publishable paper in their junior year. They're going to try to, right? Research paper. So he says to them, look, and the important thing to know here is that the lowest passing grade in his course is 70. There are no Ds. I don't believe in D's. I've never understood why we have them. I don't give D's. I think it's a crazy thing to do. I know it's really just to scam the federal government out of student loan money, right? That's why we have them. So let me ask you this. Do you want to go to a D dentist? What do you think? Do you want your kids taught by a D school teacher? Want to be flown by a D pilot? Right? No, of course you don't. That's crazy. So stop giving D's. So he doesn't give any D's. So 70 is the lowest passing grade. You could get a perfect mark in argumentation in your paper and a perfect mark for the content. You'd still only get the lowest C- possible. These are juniors in economics. They want to go to grad school. They don't want to get a C, right? So what he says to them is, look, I have a PhD. I'm a tenured professor. I write articles. I review for journals. This is what I do for a living. This is why the university hired me and promoted me. Therefore, I am competent to evaluate the creativity and excellence of your work. I do it with other people's work in my field who have PhDs. That's what journal review is. So I'm going to give you the benefit of that expertise, and that 20 points is what he uses to raise students' gaze, right? So he says, remind me of your name, I'm sorry. Isaura. He says, Isaura, I've known you since you were a freshman. And I'm looking at this draft of yours and I'm thinking, that's a good solid draft. It's competent. But I know you can do better work than this. So here's what I want you to do. I think you can make this more creative, more interesting. Because when you apply for graduate school, everybody who applies for a good graduate school is competent. You got to show them you got more than that. You got to show them that you have some individuality, some creativity. Let's talk about how you can do this in this draft and how you can finish this, right? So Isaura goes back. She wants to get an A. She wants to do really well. She's got some things to think about. And I can raise the roof as high as I need to above her head. So one of the problems with rubrics is often they have a low ceiling. Everybody gets an A or B, right, with rubrics. So what I want to do is have a rubric where I can keep raising the ceiling if I need to over the students who are potentially high achievers, who are well prepared and hardworking. Now, anybody who does the work and does it competently is going to pass. I can promise them that. I'm not going to lower the floor. But the floor is the floor. It's a C. What I'm going to say to them is, you get a C in economics and you don't go to graduate school, you're going to be working for the government. With a bachelor's degree in economics, you're going to be working for the state or the federal government. That's all you're going to get. That's okay if that's what you want. So you tell me when we meet if you're happy with a C, and then I'll give you feedback appropriate to that. So before he meets with the students, this is what happens. And this is the critical part of the story, okay? First, they assess their own draft on this. Then one of their peers assesses their draft on the same rubric in a different colored pen. With me? Then they're expected to work on it and redraft it and revise. Then the graduate teaching fellow, because they're big classes, right, more than 100 students, the graduate teaching fellows read them and give their feedback, and the students are expected then to revise them again. So they're doing this for the first 6 weeks of class. It's a big project writing this article. By week 6, the professor says to them, if you have assessed it yourself and rewritten it, and if the graduate teaching fellow has assessed it and rewritten it, they have to, you can send me the rubric and those drafts and I'll review it. So he's now reviewing a third or fourth draft. In other words, he doesn't have to read garbage, right? If they can't hand in the drafts and the rubric, he won't read it. They know that. So they know from the beginning that if they don't follow the steps, he's not going to read it. And if he doesn't read it, they're not going to pass. Not going to happen. So he reads them in about week 6, and he wipes out a whole week of classes and meets with every student to give them feedback on it. But before he does that, he says, tell me what grade you'll be satisfied with on this. You know, how much work are you willing to put in this? Are you going to be satisfied with a B, an A, a C? Those are the 3 choices, right? And so they tell him, so he knows. So when he meets with them, he gives them feedback related to what they want to do. If they've written something solid and it's a good C paper, he just says, look, these are the things you need to do to finish this. You know, clean it up, do these things, get your citations right, add a conclusion, you got a C. The students who say they want an A, he's going to give a different kind of feedback to. Is that unfair? They've opted. They've said what they want. right? So he's not wasting his time giving feedback about, doing a better job if they don't care about doing a better job. Then they have 6 weeks to finish it. They can get feedback from anyone, including him. But here's the thing. He sends them a summary, an email after his meeting with them, summarizing the advice he's given them, the feedback he's given them. They must respond to each point in the email. They have to send him an email back responding to his feedback. They can say, point 1, I'm not going to do. I don't agree with that. I'm happy with it the way it is. But they must respond. If they don't respond, these are juniors. If they don't respond, he won't read their final paper. And if he doesn't read their final paper, they fail. So what he says to them is, I'm spending a lot of time reading your draft and giving you feedback. I expect you to take time to read my feedback and respond to it. That's what it means to be a person, in a discipline, to be part of the economics community. That's what we do. So you can imagine the students respond, right? Then he reads the final paper, and what he's reading at the end of the semester is, in some cases, the 9th or the 10th draft. The thing. It's the best work they can possibly do. So he's grading them on the same rubric. He doesn't have to write comments, and he doesn't. Because writing comments on students' papers or exams at the end of the term is wasting your time. It's too late. Not going to do any good. He's already given them feedback. He knows that they've had a chance to read it, and he's grading them finally on the very best work they can possibly do. Right? They've had the time, they've had the feedback, they've had the opportunity to do it, and they've made choices about how good they want to make it. Now, does everybody get an A? No. Does everybody who wants an A get an A? No. But they've had the best chance they could have to get an A. All using the same rubric. Nothing changes about that, right? Except where they are on it. So I've taken some time to sort of go through this slowly, but the key to the anecdote is this. Feedback only helps if it's consequential and if it comes at the right time. It can be timely, but if students don't think it matters, they may not use it. If they think it matters, but it's at the wrong time, they may not be able to use it. So some of you probably spend a lot of time giving students feedback, and you might be working too hard for the results that you get. You might ask yourself, could I move it a bit in the semester, or do it a bit differently and get a bigger return on the investment that I put into it, that you put into it? So think about that, and you might write yourself a note on page 12. Yeah?
Is there somewhere that describes it?
If you'll send me an email, I'll see if I can find a succinct description. Okay? Yes?
Based on your rubrics, even if expectations exceed theirs.
So if all you do is meet expectations, you still don't get a C minus.
You don't get a C minus. Yeah.
And what he's trying to say, these are juniors, they're majors. He's trying to say to them, it isn't good enough just to do the minimum. It's not good enough in this anymore. Might have been in your freshman year, that expectation. But when you're in the work world in this, it's a highly competitive field. It's very difficult to get a job in economics without a PhD now, much less with a BS. So he's trying to say to students, look, we've got to raise the bar, and I'm going to give you time and help and feedback to raise the bar, but you've got to care about it enough to do that. Page 10. So a couple of people may have seen this today. Saura saw it, I think. On page 10, I'm going to ask you this question. They've already been asked. Or give you this task. Circle anything on page 10 that does not look like the student feedback or student evaluation forms you're used to here. Is there anything on this that's different than the forms you use at UNT Dallas? And if there is, circle it. Just notice any differences. Do you notice anything? What's different?
The first section.
The first section. Everybody see that? Okay. Now, I didn't know whether it would be different or not, but I know that it often is. Why would I ask students to evaluate their own behavior in relation to the course and the teaching?
They can learn from the experience.
Well, it's good for them to think about it, isn't it? I mean, if they're not responsible, if they don't think about it, that matters. And so I want them to reflect on that a little bit. There are two other reasons. One is, and I said this, so I apologize to the people who heard me say it earlier today when we were talking, that research on survey research on doing surveys shows that on average, if you ask people to reflect on their own behavior in relation to the phenomenon that you're researching, that you're surveying, before they evaluate someone else on that, they will give you more honest and more thoughtful answers, right? So if I want students to evaluate teaching in a course, if I ask them, think about what you've done here, they're more likely to give thoughtful and reasonable and accurate answers than if I don't. And so it's important to me to try to get good data when I'm looking at feedback on teaching. It's really consequential, and I want to do everything I can to do that. The other reason is that if I have answers to those questions, I can correlate those answers to other responses in this, and I can answer questions my colleagues often have. Like my colleagues often think, students who don't work very hard or get a good grade give me worse evaluations than those who get good grades. The research on this is quite clear that that's usually not the case. That's not true, but almost all faculty believe that. So if I have data from our students, I can prove to them on our data whether that's true or not. We can see it. And so it gives me a chance to answer some of those questions through correlation. Yeah.
For clarification, when you're saying that the data shows that you ask
Reflect on their own behavior first and then the course and the faculty member. On our surveys, those questions come at the very end.
Yes.
And ask yourself, would it be better if you moved those? And my answer would be, based on what I know, yeah. But you could ask, someone else who's a survey research expert on campus what they think. It's good that you ask them, And the question is, does sequencing matter? And in some things, sequencing matters. The order in which you ask questions sometimes has an influence, So, this morning I met with some of your colleagues on the faculty, and we were talking about the evaluation of teaching and courses here, and I know that you guys are going to be working on that. And the good news is the technical problems of doing that have been solved, as far as I'm concerned. We've known how to do this well for a long time. Any technical questions that any university has about how to do it well, almost any, have been a known quantity for a long time. You can get somebody to answer that for you, or you can find it. It's a cultural problem. It's not a technical problem. And so it's really about what kind of place do you want to be? What do you value? What do you think really, good or excellent teaching is? Those are the hard parts. Once you figure that out, measuring that and the techniques of doing that are really not hard. So I would concentrate effort on really trying to figure out what do you really value? What matters? Because the rest of it is, a technician like me could do that. That's easy to do. So I developed this form years ago for one of the colleges I taught at, and it's been adapted and adopted by a number of other places, and people have actually done research on it, which is interesting to me. But it's there for your, information. Now let's turn one last time to page 12. Write down anything you might want to write down. Possible applications. So we've got a half hour, ostensibly, to go. Are you still alive? Right? You're still functioning. If we take a 3-minute break, can you be back in 5, ready to do the last few minutes? Right? So let's just take a really quick break and start again, and then we'll do the last few minutes and try to make some sense of all of this. 3 minutes. On each table, I put a pile of the second handout. if you would hand those around, I'm just going to touch on maybe 3 pages of this. And one of the reasons why there's redundancy between the 2 handouts is I didn't know in advance whether the people who came to one session would be at all the same people who came to the second one. And nobody really could predict that. We didn't know, right? So I'm not going to go through all of this. There are things you could read in this, but I'm going to touch on a couple of things that we haven't talked about that might be useful. Might be. I hope will be. And so I'd like you to turn first to page 2. And you'll see the list of all those terms again. It's the same list. Okay? Would you put a check mark by any of the ones, any terms that you think you've learned something about in the first, till now, since we started? So put a check. Yeah, if you think you've learned anything more about any of these terms, put a check mark next to them. The ones on page 2 on the first half of the handout. This is the second handout. Sorry, it's the one that says finding out on the front of it. Yeah. It's the same list. Put a check mark by any ones you think you've learned something additional about, if there are any. So one of the reasons that sometimes we get the kind of evaluations that we get from students at the end of the course is sometimes students don't realize that they're learning anything, which seems odd, but it's the case. And one of the things I try to do is to get them to reflect as we go on what they're learning and what they're not, but to sort of remind them that, a week ago you didn't know anything about several of these terms, and now you're pretty sure that you do understand what they mean. Or when we started, you said you didn't have these skills, and now you've actually made some progress on them. Because it's often hard for us to remember, back that in fact we didn't know some of these things or didn't know them very well. So I try to get students to actually reflect on that and realize that they are making progress in addition to the progress that they gauge by their grades, which is the primary thing for them. Right? There's more to it than that. Do you see this pyramid below that list? There's a triangle there. I want you to draw a picture or draw something in this triangle. So imagine that this triangle represents 100% of all the teaching that you're going to do in one of the courses that you're going to start next week. So pick a course to focus on for a minute and write the name of that course next to the triangle. One of the courses that you teach. Any course, but one that you're going to teach this semester. And write the name of that course there to remind you which one you're thinking of. And in just a second, what I want you to do is I want you to divide that pyramid up based on how much of the course you think students can teach themselves. Students can teach each other. They can learn from more advanced students or tutors, maybe if you have them. And what portion of all of the learning in that course do they have to get directly for you? Now, I've divided it equally, but I wouldn't expect yours will be divided equal. This is just to sort of say what's there. So put a line, where you think this is the amount of what's going on in that course they can teach themselves if they do what I ask them to. How much can they teach each other if they do what I ask them to? If you have access to more advanced students or tutors, how much of it can they get help from them? And what percentage of all the course do you have to teach them directly? They can't get anywhere else. And just rough it out. Just sort of approximately. And take a look at your neighbor's drawings and see if they in any way resemble yours. Remember, you're all teaching different things, so you'd expect they'd be different. So did most of you sort of say, equal parts each? Did any of you think you have to do more work than the students have to do? Now, here's what I do with this. You could do it a number of different ways. But I do this with the students and early on, and I ask them, what percentage of everything that's going to happen here do you think you're going to have to do yourself? And what percentage do you think you'll do with other people? What percentage do you think I am responsible for teaching you? Can you imagine what theirs look like? The undergraduates? It's mostly me. And so then I show them mine, right? And it's usually pretty different than theirs. And I say, let's talk about this for a minute. You're coming in here with the expectation that I'm going to teach you everything. And I'm coming in with the expectation that you're going to teach yourselves some of this. We better get straight about that now, before it's too late, so that you understand why I think that you need to teach yourselves some things, and which parts of it I expect you to teach yourselves, and what you can do if you're struggling, But I am not going to cover everything in the textbook and everything that's going to be on the tests in the same depth. And some things I won't even cover at all when we meet. Here's why, because some of those things are things you can do. And then I try to give them examples of the things that they can teach themselves. But I want to set their expectations from week one, very clearly about the fact that despite what some dialects of English suggest, you can't learn anybody anything. They got to learn it themselves, right? And if they're not ready to do that, it's not going to happen. Not much is going to happen. So I'm willing to shoulder a lot of the burden, more with first years than with second years, more with second years than with third, This distribution changes over time. But I'm not Atlas. I can't hold up the world. They got to help. And some of them, when they come, especially when they first come to college, are used to probably getting more help than might have been helpful. Some of them are sort of in a learned helplessness mode, and they expect teachers to do everything for them. And I understand why those teachers did try to do everything for them, but I'm not sure that helps in the long run. I think that's problematic. They're going to find college won't work that way. And sometimes I think we don't tell them why. Here's why we're doing this differently. Why it's not like high school might have been. Okay? I'll skip page 3. You could teach yourself that, and I'll skip page 4. And page 5 we've sort of done. Page 7 is a reiteration of that stuff on group work. And so on page 7 I've given you this in a checklist form so you can ask yourself when you're planning group work, have I thought about this yet? So some of you asked about that. I'll just say that the single most common mistake most people make with group work is they assign students something to do in a group that some of the students could do better on their own or faster on their own. And that's the single simple mistake that most people make. So if you're going to give students group work, it needs to be something that the smartest and the fastest and the best prepared students cannot do on their own. Otherwise they will, and the rest of them will wait for them to do it. Right? And I'm sure you've seen this sometimes. And that means that the smart person gets more practice, but they're angry because they did all the work, or the better prepared student. And the other students are freeloading, right? So they're not learning anything, and they're hoping that they're going to get points for that. That leads to bad attitudes, I think, and bad behavior in group work. And that happens a lot, unfortunately. So on page 8, I've given you a form that I use to get students to think about their responsibility for group work. So if you take a quick look at page 8. So imagine we're in a group of 5. That's why there are 5 numbers here. Right? I'm asking students to turn this in. They do it online, and I then give them feedback about what they've said about their group. So if there are really different answers from different people in the group, I may need to call them in if they're going to work on a project over time and say, let's talk about this. You don't seem to be agreeing on whether this is fair or not, whether people are actually pulling their weight. So this gives me a chance really early on to intervene in major group projects before things go too wonky. Every group is going to have some strife. I know that. And so what I want to do is try to prepare them to manage that. Now, if you're interested in using group work in a very serious way, and you're in a discipline where people use that in a very serious way, excuse me for just a second here, you might want to look into something that's called teamwork, because there's especially as it's used in engineering and in business, because there's a really highly developed technology for using teamwork in business and engineering, and a lot of things written about it in a very disciplined way. And the person who's written most of this is a man whose last name is Michelson. So if you want to read about teamwork and how to use teamwork in a very disciplined, serious way, Larry Michelson is the person who's most famous for this. And I think Larry Michelson lives in Oklahoma, actually. I think he's at the University of Oklahoma. But he's sort of a world figure. He often goes to China and other countries and works on this. And he's written a lot of good books and articles about how to do teamwork, if you're going to do it in students working over weeks in a team to do a project. Okay. Page 9. At the top of page 9 is Bloom's taxonomy. How many of you have seen Bloom's taxonomy before? So it's pretty widely known. If you haven't seen it, it's easy to understand. If you don't have a handout, we have plenty of them, so get you one. Here's what I'd like you to do. I'd like you to look at the questions A through J below. Got one. Page 9. See those questions? I want you to identify for each of those questions, A through J, really quickly, which level of Bloom's taxonomy are they asking? Which level is each question at in Bloom's taxonomy? And just put 1 or a 2 or a 3 or a 6. So let's do number 1 together. Give an example of seasonal change. Could a person just memorize an answer to that without understanding it? So probably 1 or 2, right? Either of those it might be, but it's not 6 probably. Okay? So go through and just label them really quickly and see what you come up with. And if you're still in the top half, you might jump to the last 2 or 3 and do those. Skip the middle ones if you're still stuck. All right, looks like most people are pretty much done. This is a good time for you to stand up, find a person at another table, and compare your answers for a minute. And I want to know whether you're within one step, within one level of Bloom's taxonomy on most of these with the other person. So stand up, find a partner at another table, quickly compare your answers, see if you're within one on most of these. Like 5 or 6 or 2 or 3.
Six, no, 3. So it's 4, 5, and 6. You can do 4, 5, and 6. Yeah. You can analyze, break down, unique part, and whole part. But yeah, but then again, it can be this and this too, right? Some people it just works. That's okay. Remember these things. If it's winter here, then it's going to be summer there. Summer here, then it's summer there. Close? Now, wait. No, but kind of. Go the bells.
Memorize the name of your new friend if you can. Now, this is called by a lot of people blooming, doing this, and it's blooming because it's Bloom's taxonomy. What it is just taking tasks or questions and trying to figure out, where on Bloom's taxonomy, you could use any taxonomy, there's more than Bloom's, but it's a common one. Where do these questions that I'm asking students to answer fall, or these tasks that I'm asking them to do? So that we can decide determine the level at which we're asking students to operate intellectually, and decide if our exams and if our assignments are operating at that level, or enough of the questions are at that level, right? So one of the things I suggest to people is, one of the most powerful things you can do if you have multiple sections is have common exams. Do you have multiple sections of some courses? Right? So if you have common exams, that solves a lot of problems for you, right? Because it means that students are held to the same standard. It means that they can't go to another section to try to get an easier grade. It means there's more fairness, blah, blah. So if you're creating a common exam, everybody can write questions, submit those together, and then you can do a blooming exercise where you identify what Bloom's level you think it is, and then other people, on their own, without seeing what you've written, try to identify their level. And then you get together as a group and try to decide, which of these questions are at which levels, and how many questions do we want at each level? Do we want to go all the way up in this test or this assignment? And do we want to put most of the questions at a higher order level? So remember I talked about HOTs, hot hips? Hot means higher order thinking. And most people, higher order thinking. And lower order thinking is lot, right? So there are hots and lots. Most people would say, there's some disagreement about this, most people would say that higher order thinking in Bloom's taxonomy probably begins at least at analyze. Maybe above that, right? But most people would say somewhere around analyze. So those are the hots, the ones above that. So when we're looking at our homework, our quizzes, our assignments, we want to say, what percentage of the grade should depend on HOTs? Things that are really higher order thinking questions. And which percentage of the grade are we going to do on LOTs? So what I say to students is, everything that matters in this course is up in the HOT zone. You have to learn the LOTs. You can do that on your own. The stuff that we're going to spend most of our time working on together is in the HOT zone, because those are the hard ones. So memorization, understanding, those simple sorts of things I expect you to do on your own and with each other. You can figure that out. I'll give you some hints. I'll give you some ideas how to do it. But you're responsible for that. The exam and assignment questions are all going to be up here. I am not going to ask you questions that require memorization on the exam. That's my choice. Other people might think they should. That's good. But it's thinking about that seriously and letting students know what's going to come. So I say, yeah, you got to memorize stuff. A lot of stuff you got to memorize. Other stuff you can look up. But I'm not going to grade you based on those things because that's trivial. It's a waste of time. That's just the preparation for learning the more important stuff. So the HOTs are those things that are difficult, that students might struggle more with, and that I expect, if we look back at that triangle, I'm going to say, these are the ones that I'm really going to give more attention to and try to help you with and give more of my effort to. So if that suggests anything to you about your assignments, the questions you might ask next week, you might want to write yourself a note about What level of Bloom's taxonomy? And one way to do this is to actually sort of step the questions up when you're having a class discussion, to start with lower order questions, to warm them up a bit, and move up. Right? So people sometimes do it that way, use Bloom's taxonomy to help them do that. Did any of you find questions in here that you thought were at level 6 on this page? Some are saying no and some are saying yes. So let's hear someone say what one yes was. Jay needed creativity, basically, to do that. Yeah. So we might say that. You'd have to imagine. Could you look this up and find an answer to it? Potentially, but you'd have to read an awful lot, and you'd have to understand what you read. So I'd probably be okay with that. If a student was willing to go read a lot about Earth-like planets, right, and do a lot of research on that, and they came back and answered this question having done that, that probably wouldn't be the end of the world for an undergraduate.
Someone had a question.
I put I, which is explaining it to a 7-year-old, because I think you would need to be creative in explaining it if you do a good job of it.
You don't know about human behavior, you have to at least be able to understand how a 7-year-old thinks.
So here's my question for you. This is essentially, although you're not dealing with 7-year-olds, this is your job, to explain really complicated things to people who have no idea what you're talking about. Do you think that requires creativity? Well, it does, right? So unless you memorize a lesson from some book that tells you how to talk to a 7-year-old, which I don't think would work, with most 7-year-olds, you're going to have to figure this out on your own. And I think that is a highly creative activity, to be able to teach well. It's one of the hardest things anybody does when you do it well. So I'm going to end on that note. We have an evaluation form at the end of this. If you'd like to give me further feedback, please do. I'll take those and read those and summarize those. But I think you've suffered enough. Thank you for your time and your effort. I wish you well.
There are two people
And probably a lot of people made this happen, but I'd like to thank you for everything you did to get this together, and the provost for making this happen. Because whenever people get together like this, it's kind of, it's easy to forget that this took a lot of planning and a lot of effort on the part of people here to make this happen, and that's been going on for a while. So I appreciate that. Good luck. If I can say this because it rarely happens, but if anybody actually does have a question that you'd like to ask me now, feel free. And if you'd like to email me. Out of every 100 people I talk to, about 1 emails me, so I'm not too worried, but feel free if you want to. Good luck next week. Have fun.